right, so we're going to get started because we can, and let's be on time, and we have a lot to learn today. So I want to make sure we have time for everything, and I'm sure people will continue to join as we move forward. So hello, everyone, and welcome to Carbon Drawdown Now, building to combat the climate crisis. We're so glad that you could join us today from wherever you are to celebrate the 50th anniversary of Earth Day. I'm excited to learn something new with you all that can help us take action on climate change now, as promised. I think it's a great way to honor the collective spirit of Earth Day, even as we are physically apart. So I'm Sarah Draper. I'm the director of the R.W. Kern Center at Hampshire College. We are a net zero energy, net zero water, and net zero carbon living building. And it's our mission to be a working model for green buildings everywhere and to help others, like potentially some of you guys, create sustainable places for people and for the environment. I do want to thank tonight's sponsors, Bill and Leona Kern of the R.W. Kern family. And lastly, we are excited to partner with NESEA to bring you this content. I'd like to introduce Florence McGregor of NESEA to welcome you all and to get you oriented with some of the technical features needed for the webinar.
Thank you, Sarah. So yes, I'm Florence McGregor. I'm the Senior Program and Community Engagement Manager at the Northeast Sustainable Energy Association, better known to many of you as NESEA. So for those who are new to NESEA, we are a member-driven organization operating in the 10 states in the Northeast. Our mission involves cultivating a community of practitioners to advance the adoption of sustainability in the built environment. So cultivating community is something we would usually be doing at in-person events, but tonight we're so glad to be working with the Kern Center and the team from New Frameworks to cultivate community in this way. Part of our vision statement involves picturing an adaptive and resilient future. And this is sort of how we're all collectively adapting to the current challenges and being resilient and not letting situations take away from our mission. And so we're so happy to have the opportunity to work with NESEA members, both from our academic membership with Hampshire College and the Kern Center, and our business membership, the team from New Frameworks. We've worked with both of these partners closely to bring this. So that's all from me. And thank you all for joining us.
Cool. Thanks, Florence. So I'm excited to introduce our speakers for tonight, Ace McArleton and Jacob Deva Racusin. Jacob and Ace are the founders of a Vermont design and build firm, New Frameworks. Some of you might be familiar with New Frameworks. They specialize in sustainable and natural building. And these guys are well-known experts in embodied carbon and low carbon materials, and I know you will learn a lot from them. So take it away, guys.
Thank you so much, Sarah, and thank you everybody so much for coming and joining us on this really special day of the 50th birthday of Earth Day. We both feel really honored and excited to be here with everyone. All right, so welcome to Carbon Drawdown Now. We are going to start with Greta Thunberg. Many of you are familiar with Greta. She was and is, she is an activist, was a 15-year-old when she began Climate Strike on Fridays for Future. And I just wanted us to kick off by thinking about, for a moment, what the question of a strike is. A strike is when we collectively withhold our labor and resources from an activity that we may be socially bound to, yet it harms us to continue it. So Greta saw no point in continuing honoring the social contract of going to school and to get a job and then to go to work in a society locked in a trajectory that would lead ultimately to her death, the death of friends and family, the death of creatures and species, and the rest of our planet, hence our future. So I think it's useful to think about how a strike is a pause. It is a pause in business as usual that calls out a crisis. So a strike does not create a crisis, it calls out a crisis that is ongoing and says, I'm going to call you on this crisis, you are happening. And in that moment of pausing and withholding social consent for such a thing, we open up space to imagine a new future. So as has been said, today is Earth Day. We're celebrating 50 years of Earth Day. I think it's worth noting that designating one day in a year where we honor and remember Earth and our relationship to Earth says a lot about the dominant system of values that we're operating under. Yet, the naming of Earth and our relationship to Earth and planetary systems represents the intention, the re-intention of balancing that and rebalancing that and creating space for such a marginalized yet critical thing in our society, moves us towards renegotiating power in a critical way that we very much need in order to move forward. So Sarah acknowledged that we're not here together tonight in one room. And the reason for that is that we are in a pandemic, the COVID-19 pandemic. And I think it's worth noting that this has forced some of us to pause normal activities and business as usual. And I think it's worth noting that it has caused others of us, those in Black and Brown communities, on reservations, in prison systems, and in the immigration system, have simply seen an intensification of the violence, death, and being deprived of resources that communities are all too used to, yet are intensified in this crisis. So in some ways, I think it's really useful for us to acknowledge that there has been a form of a social pause and a social non-participation as a result of the COVID-19 pandemic. In some ways, business as usual has been disrupted, and in other ways, it has merely intensified and shown its ugly, terrible roots. So, but I do think it's worth noting that we're seeing the effects of the disruption of business as usual in cleaner air and water, more room for wildlife and animal life. And I think that this pause that has opened, again, gives us space to imagine that social transformation that we so deeply need. And so we want to open with really thinking about that systemic connection that we all have through these different forces. Author Arundhati Roy wrote, "Another world is not only possible, she is on her way. And on a quiet day, I can hear her breathing." We intentionally did not title this talk, Understanding Carbon in Buildings. We intentionally titled this talk, Carbon Drawdown Now, because informed action is necessary to build this new world as it is in our hands. So moving on to our message, our simple message is that we want to create zero carbon and carbon storing buildings for everyone to address the climate and social crises. So this is what we're going to charge all of us with tonight. And we bolded the part of the sentence "for everyone" for a reason, because even though this is a simple goal, many of you know there's one, a lot to this, and two, though housing everyone and everyone having shelter that is regenerative, healthy, and safe is a human right, it is not one that is currently enjoyed by many on this planet. So there's a lot packed in there that we need to work on that is interconnected. Which leads us to the second part of our mission, looking at it in a systemic way. So one of the reasons that we end up with so many discrete problems that actually tend to magnify other problems is because we have not been taught often, in the dominant society, to think about our lives and our work and our place as being interconnected. We think about things in silos and in boxes, and that leads us into a very difficult place. So this broad interconnected view is what we are going to be working on tonight.
So this is to answer this problem of the climate crisis, which is, most simply and most frequently identified as an overloading of greenhouse gases in the atmosphere. We've seen a tremendous escalation of that over time. And this is sort of where most of our attention as this is sort of generally focused in taking climate action, reducing climate, the increase of greenhouse gases in our atmosphere. But if we were to just focus on that and simply change the atmospheric chemistry of the planet, that would not get to the root and to the heart of solving these myriad interconnected problems that we're experiencing. It's not as, that's an oversimplification of the depth and complexity of the problem. And there truly is a systems problem. If there's one thing that we want you to take away by the end of this presentation, it's an orientation around systems thinking towards the complexity of these issues. It's important to be able to simplify things for the sake of convenience and some general messaging, but it is not just a matter of chemical imbalance in the atmosphere. That is one of a series of different problems with common roots in an extractive economy that has led to so many of the issues that is highlighted in the introduction that we're experiencing under the influence of this pandemic as well. There's tremendous overlap in social and ecological problems that come from common sources. And so while that is, there's a systems, there's a system in place that is causing myriad problems, of which atmospheric chemical imbalance is one. But that gives us an opportunity to look at solutions from a similar standpoint. So looking at the simple solution to the simple problem is that we need to dramatically reduce our emissions, right? And the International Panel on Climate Change, the international scientific body that has sort of, nearly by consensus, highlighted the tremendous urgency around reducing those emissions. That's the simple solution, but the systems solution goes much deeper than that and provides a tremendous opportunity. What we see is that while a systems problem requires systems solutions, solving these problems on that level allow us to address multiple different issues at the same time. So it's not going to be just a matter of making some simple material swaps in our buildings, reducing our emissions and saying, job well done. It's going to take the work of organizing ourselves as an industry with allied industries and partner industries and holding values around social equity and climate justice and looking at the range of ecological impacts that come from our buildings. But addressing it on that level will dramatically magnify the positive impacts that we can have in our actions to that end.
All right, so on the note of interconnected and systems thinking, before we launch into this section, we are going to ask folks to answer a quick poll to get our sort of juices flowing on this. So you should be seeing in just a minute a poll pop up on your screen, and we're going to ask everybody to just answer it to the best of your ability from wherever you are. And there it is. So this is about the carbon cycle. So when I am in a room, I ask the room, can people raise their hands? How many people have heard of and are familiar with the carbon cycle? Since we are remote, we're going to do something similar, but going to ask you all to click one of these answers here, either yes, no, or sort of. That's our technical term. So Robert is kindly gathering the results of the poll on the back end, and he is going to...
Well, actually, yeah, we'll give everybody about 5 more seconds. It's almost 100% complete.
Oh my God,
Right.
You all are quick.
Thanks, everyone.
We've got folks quick off the mark here. I can't wait to see the results. All right. Hey, that's pretty good. So we've got a split about, so 55% yes, 40% sort of, and then a few no's. That's great. Every group has a different, sort of approach to that. And that's great to hear where everybody's at here in the group. So we are going to be starting by talking with about the carbon cycle. So for those of you who are unfamiliar, this will be a good, dip your toe in. And for those of you that are familiar, I hope this will be a refresher and helpful. And for those of you who are like, kinda, this will be, again, just hopefully a good sense. And we're not going to go too deep. We're just going to give ourselves a good setup to be able to understand what we're saying about embodied carbon tonight. And that's our aim. So again, if you've got Q&As that you want to send us in the Q&A section, please do that. And we'll look at those, you know, later and address them. So interconnected systems thinking, carbon cycle. All right. So the carbon cycle is a biogeochemical cycle. So that means it interfaces with biological, geological, and chemical changes and movements of carbon through those different places on the planet. So what we're seeing in the picture is an example of the different areas and spaces of the Earth that carbon is moving through. Jacob mentioned greenhouse gases on an earlier slide, and I think many of us are familiar with the fact that climate change is an overload of greenhouse gases in the atmosphere. And that in this particular moment, we're talking about carbon dioxide and other forms of carbon that are gaseous, such as methane. But carbon is so much more. So I want to start out by saying, we love carbon. Carbon's great. It's a part of, it is the basis of life on Earth. It is the fourth most abundant element on Earth. You know, our DNA is molecules twining around a carbon stem. You know, it moves in these forms from rocks to oceans to atmosphere to soil to plants to animals and back again. It is a dynamic and moving system. And I think what's critical for us to understand is that an overall balance in the system is critical to maintain temperatures and, you know, habitable life on Earth. As a very brief example, many of you may be familiar with the planet Venus. Venus is extremely hot, and a huge reason for that is the intensive greenhouse gas presence there. So it's critical for us to make sure that we are working in a partnership way and respecting this critical system on our planet. So what has been happening, which many of us are aware, is that stored carbon in the form of fossil carbon, so you can see that on the bottom left here of the image, has been mined, pulled up, drawn up, primarily since the Industrial Revolution in the mid 1700s and 1800s. Coal was used for long times before that, but in small ways. But during the Industrial Revolution, we got a major upswing in harvesting coal, which is the result of dead plant material that has been laid down 300 million years ago. And then oil and gas is dead marine organisms. So the deforestation and land use changes that we also see shown on this slide are also a part of the loss of carbon into the atmosphere and into the overloading the atmosphere. So we see a lot of red arrows going up, and we see, like in this picture, one arrow going down. And so that's critical to see the combination of the fossil carbon that's being transformed and burned and into atmospheric CO2, and then the soil carbon that's being released as a result of the deforestation and the land use changes. And the only thing that's bringing that arrow down is the green arrow that says photosynthesis. And so on our next slide, we have just a reminder of basic photosynthesis. You know, I don't know about you, I remember learning this in sort of 8th grade biology, and it's incredible to me, really, what photosynthesis does for us. It's massive. So plants, both in the oceans and marine organisms, and then the like phytoplankton, and then on land, grasses, you know, trees, all plants, convert light energy with gaseous CO2, so from the atmosphere, and water to create stored chemical energy in the form of carbohydrates. So when plants do this, they are essentially storing carbon in a fixed form, or it's not fixed because it can be transformed, but in a chemical form. So we're converting a gas, well, they are converting a gas to a solid stored chemical compound. And so what we're seeing here is also a pretty interesting relationship between the plants above the soil, where we see about a 30 to 50% carbon content. And then below the soil and the roots, there's a really important thing occurring, an interaction between the soil fauna and microbes and the soil fungus around the roots of the plant that are helping to store even more carbon in the form of humus into the soil. And so that soil organic matter becomes a really, really, really key important part of storage. And actually, as we see here, the plant roots can generate 1 to 3 times as much carbon storage as the plant itself. So this is important for us to understand as we're looking at how to maximize this storage mechanism. So again, this positive intervention that we're proposing is, the first one's pretty basic. Stop moving carbon from fossil fuels to the atmosphere. Hopefully a lot of us are working on that one, and secondly, we then, the carbon that is there and that will probably still go there in an unbalanced way through burning and land use practices, everything we talked about, we need to move that carbon into the biosphere quickly. Really briefly, there are 2 kind of speeds of the carbon cycle that are acknowledged. One of them is the fast carbon cycle, where we're looking at literally a daily transformation of carbon through its forms, whereas the long carbon cycle is, millions of years, more like geologic time. So what we're talking about is intervening in this fast carbon cycle, where we're saying, how can we utilize this incredible thing that plants are doing? I didn't even mention that they release oxygen that we breathe. Food that we eat. There's many things we could say, but simply in this lens of looking at carbon storage, we are looking at how do we partner with plants through this natural process that they are already engaged in, and maximize that to help honestly correct this mistake that we've made through burning fossil carbon and land use changes and all the things that we said. So we are talking about taking that carbon from the biosphere and storing it safely in our buildings. And so we talked a little bit about this earlier, I mentioned it, but one of the things that we'd like to propose is that the success of a building, whether or not a building is considered zero carbon or carbon storing, can be measured by how much the soil was built as a result of that building. So we're talking about really looking down the whole chain of generation and supply and full life cycle processes around the buildings that we're making. And this is a huge challenge for us. It's going to be a new way of thinking and a new way of working, but we welcome that challenge. And so the soil, just as a quick sort of statistic, the great potential in soil storage that exists is that if we can restore soils, it will essentially be equivalent to taking 3.5 billion to 11 billion tons of CO2 emissions off, out of the atmosphere annually. And the sort of annual emissions from fossil fuel burning is 32 billion tons. So that's significant. It's like a third, on the high end. So focusing on soil is a huge thing. And, we have more carbon residing in that soil than in both plant and animal life combined. So it's, again, a significant place to work and to safeguard in our processes. Well, the slide is a little bit slow, but okay, there we go. So our simple solution, again, working with that simple and then systems level, we can see on the left the natural system, emblemized by the forest, and then the removal of atmospheric CO2 during growth, carbon drawdown process like we talked about, and we have that plus our emissions from manufacturing and harvesting, which amount to carbon emissions. And then we can see at the end our net carbon storage. So this is kind of the very straightforward thing. We work with plants, we have emissions, we draw down. Now here is what we're talking about in terms of these system solutions and how we start to really leverage the success that we can have and the impacts that we can have. So on the left, you'll see that the natural system is a little bit bigger than it was in the last one, a little bit more diverse, a little bit more ranging. We see that same thing, the removal of atmospheric CO2 during growth that plants do naturally. And we have a beautiful grassland there. And we can speak about that in a minute. And then another fun thing, you can see that the tractor, I don't know if you noticed in the prior slide, but the tractor was not electric, and here the tractor is electric. And then we see the emissions from the manufacturing and harvesting. Suddenly the plant has some renewable power generation happening on it. So then we can see that this beautiful green bubble around net carbon storage with the building at the end has grown. And it is larger because we have essentially along the step of every step of the way, we have magnified the positive impacts of that process. And so carbon action in our buildings is an opportunity to decolonize our industry. I love this. So I'm going to read this quote from Leah Penniman, who, if anybody has not yet gotten her book, Farming While Black, I highly recommend it. It's an amazing piece of work. Leah writes, organic matter in soils on the plains plummeted by 50% in only one generation of white settler colonialism. I realized that all of our efforts to heal the soil entailed the restoration of organic matter and was, in effect, a decolonization of the soil. We were inviting our non-human relations back onto the land and back into relationship with us. And so there's a couple of key things here. Part of what was happening on the plains is that there were incredible networks of grasses that grew deep, very deep root systems that did exactly what we explained about, the roots interchanging with the soil and the soil microorganisms to create incredible soil carbon storage. And so there's many things that are happening in this quote. It's talking about the natural systems and how they were disrupted. It's talking about the white settler colonialism and what was imposed. And it's worth noting, we're going to talk a little bit more about carbon drawdown later in the project drawdown, later in the talk. And in Project Drawdown, indigenous land practices and supporting indigenous land use practice kind of wisdom and management is number 39, I think, or 38, I can't quite remember, but on the list. And the only reason that it's not higher is because currently only 18% of land is under indigenous control. So if indigenous control of land was larger, that impact would, potentially be number one on the Project Drawdown list. So what's critical about this to understand is that our human organization and the way that we understand and orient and have relationship with the places that we are and live is hugely impactful in terms of the effects on the biosphere and on our planet systems. So this is critical for us to understand.
All right, so let's bring this back into how buildings and the built environment plays into all of this. So looking at the sort of global emissions 2019, of all the emissions that are released in all the different sectors, we see about 28% of global emissions went to the operation of our buildings, heating, cooling, lighting, electrifying, et cetera, et cetera. And another combined 21% goes into bringing those buildings into existence, the materials that go into them and the process of construction. So, that's pull that all together and we see that the building industry, both its creation and operation and maintenance, is an enormous, chunk of that pie of our global emissions. And so as people that live in buildings and work in buildings and create buildings, those of us within the building industry, the onus is great upon us. So just to highlight the percentage or the scale of impact as on a global perspective as it relates to buildings, here's our mandate. That's our impact, and so by association, that's our mandate to intervene in the scale of our emissions, looking specifically at that portion of the cycle that is migrating carbon dioxide and equivalent global warming gases into the atmosphere. So let's break this down and look at sort of the full life cycle of impact and get a little more specific about where those different points of emissions are released so we can really understand where our greatest points of intervention are. So when we look at the life cycle, and this is a life cycle either of a specific building or of a material within the building. So this life cycle sort of exists on the micro scale of a product or on the macro scale of a building itself. And it starts with the raw material extraction and processing and goes through its manufacturing into a material, bringing that material to a construction site, building that project from those materials. And then there's this period of time where the building is in its operational life. And then there's refurbishment and reuse of that building after its sort of primary lifespan is done. There's the demolition at the end of that building, and then recycling or disposing of the recovered at the end of that demolition process. So all of that together, those are all of the different phases in which we see emissions being released, again, either in the development of a product or in the development of a building. So historically, we focused very much on sort of just the energy side of that. And when we think about our building's climate impact, the focus has very much been looking at just the operational phase of the building's lifespan. If you remember back to that chart at the beginning there, that is where the majority of our building emissions come from. And so there's a lot more buildings being operated than there are buildings being constructed. And so that would make sense. And so it was appropriate that we're spending a lot of time focusing on that. And historically, the way we've looked at that is really just looking at the energy consumption of a building. And we would equate the energy usage of a building directly into its emissions. And the language used in the building, and we're trying to compare across different buildings of how much energy goes in there. It's the energy use intensity. So that's the language we use, or the EUI, amount of energy it takes to keep that building heated and cooled and lit and electrified relative to its to the size of the building, the square footage of the building. To really understand the emissions, however, we need to look at that, not just the energy that's being used, but the emissions impact and the climate impact of these different sources of energy. There's a big difference between energy that's created from the burning of coal and energy that's created through photovoltaic power or wind turbines. And so when you take the amount of energy and multiply that by the emissions factor of that energy, that's what gives us the carbon impact of that operational phase of the building's lifespan. But we know that that's just one part of the overall cycle, the life cycle of a building. So a net zero energy building does not mean we have net zero carbon emissions. That's super important to understand. We cannot use the the energy consumption of building as a proxy for carbon related emissions. And so to that end, we need to sort of put this in the context of the full lifespan of a building and recognize that the emissions that come just from the energy use of a building is really only a part of the larger puzzle. So I want to take a second right now and just make sure our definitions of terms are super clear, because I've already been using the term carbon a little bit shorthand relative to how ACE was using that term in looking at the global carbon cycle. So now when we're talking about emissions, when I say carbon, I'm being a little bit, again, a little shorthand about it. What I really mean is carbon dioxide, because that is the form that carbon takes when it is in the atmosphere, acting as a greenhouse gas. But it's not just carbon dioxide. Ace mentioned methane as another form. We see some of the greatest offending chemical compounds, and some of those that have the highest global warming potential in the form of refrigerants, propellants, and blowing agents. And so to be able to compare all of those different chemicals to each other and have a common metric, we use the metric of carbon dioxide. And so when you can see measured in kilograms of CO2e, that little e stands for equivalence. And so, for example, methane has the equivalency of about 80 times the impact of carbon dioxide in a 20-year period. In a 100-year period, it's around 24 or so. So that's, we need to convert that into a common unit, and that common unit is carbon dioxide. So when I say carbon, when I'm talking about emissions, I really mean carbon dioxide equivalent. And we see that CO2e, that's what we're talking about. Okay, now I got those definitions out of the way there. So what we recognize is, yes, there is more impact than what is just existing in the time of the life cycle. There's a host of periods in the time cycle of this building that exist before that operational phase. And that's what we really want to focus on right now. And this is what we're talking about when we refer to the upfront embodied carbon. The embodied carbon really would look at the entirety of carbon emissions that are released throughout the entire life cycle of that building. For reasons we're going to explain in just a minute, we're really most concerned with the immediate impact of those emissions, and that's the upfront carbon that's released. And so when you hear us say upfront embodied carbon, or UEC as initials, we're talking about these first few parts of the wedge there. And when we really unpack what's happening with that, we're seeing some similar imagery from at the beginning there. There's a lot of extraction, there's a lot of manufacturing, there's a tremendous amount of impact and a huge carbon footprint that is commonly externalized and sort of hidden or held, embodied, if you will, within what it takes to get all of those materials into production, onto a job site, and constructed into our buildings. And that is the place that we're going to be spending a lot of our time when we're looking at the embodied carbon impact. And that time scale is critical. So again, what we've learned from the IPCC, the global scientific community has, through their modeling, sort of set a benchmark of needing to get to zero carbon emissions, total net carbon emissions. And major reductions, like significant reductions within the next 10 years. So with that in mind, if we understand we have a very short period of time within which we must dramatically reduce the emissions profile of our buildings, we need to look at what can we leverage, like what are our points of intervention within that very short time frame. And so from the operational side, you've got 10 to 30 years worth of emissions reductions. That makes a big difference. But the entire whole first phase of that building's emission profile comes from the materials. It's that upfront embodied carbon that it takes, that is the footprint and the burden that building places on the atmosphere before the building is even used and occupied. So if we're trying to respond not just to the total quantity of emissions, but the time scale and the time value of carbon in which those emissions are released, to be able to hit these time-related benchmarks of emission reductions, we have to look at materials. We have to look at that upfront embodied carbon to be able to realize this goal of getting to true net zero by 2050. We cannot net zero energy our way out of this problem because there's just simply not enough time to reduce our operational emissions enough for that to get us to zero. There's just this whole other whack of carbon that's emitted before the building is even operated. So that's the phase of emissions that we're really going to be focusing on when we talk about the material impacts throughout the rest of this presentation. And so relating that back to the landscape here, we can see, and what we're going to look at next is how any given building with one set of materials can, using current paradigm of construction or business as usual that's gotten us into this problem, will continue to release tons and tons of emissions on an annual basis just by the production of those materials. What we want to challenge us and our practice in our company and our aspiration as an industry is to actually leverage the effects of natural ecosystem services that agriculture and forestry is providing us through photosynthesis and soil banking of carbon to actually turn the production of our materials into a mechanism for carbon storage and turn our buildings into carbon banks.
All right, so let's talk about those upfront embodied carbon emissions in a little more detail and take a look at them. So our colleague, Chris Magwood, who was pursuing a master's degree, he now has it, through Trent University. He designed a study as a basis of his thesis that New Frameworks collaborated, primarily Jacob, with him on running all of the numbers in terms of embodied carbon emissions and operational emissions for these two kind of template buildings that were the basis of this study. So in order to do a thought experiment around the impact of total upfront embodied carbon emissions, the study was designed to look at a single family home and a multi-unit building, and to look at both of them using kind of 4 different typologies of material choices around the building. So we're going to look at a high embodied carbon kind of profile from one of the buildings, the same building, but high embodied carbon profile materials. Typical, so something a little bit more average, not necessarily like the worst possible choice on everything. And then best conventional, which is really important because it talks about what a builder or architect could go and spec today, that's on the shelf, that's not code compliant, that's just perfectly available at the moment, but isn't necessarily known for being a low or storing embodied carbon material, that those are available right now, and we could do that change. And then the best, this green that you see on the left, is going to be exploring if we really do the opposite of the high and say, okay, what's the absolute most carbon storing material we can use, and what does that look like? All right, so let's walk you through a few slides to show you some of the results of that work. So beginning with the high embodied carbon typology. So we're gonna see here, you got your 0 line, you can see the net CO2e emissions in metric tons going up on the left. And so you can see as the building is being built from foundation all the way up through walls, windows, floors, ceiling, roof, and you can see on the right the materials listed. We're not going to go through every single thing because it would take too long, but I would encourage people to look at your slides when you get them and really digest this. So these particular materials, this is what this first typology is, and we can see that this building is resulting in releasing 212 metric tons of upfront embodied carbon as a result of the building being built in this way. So next, we're going to take a look at the typical typology. So we can see that coming up on the screen. We've got, similar thing. We're going to walk through the foundation, all the way up through the walls, windows, all the way up to the roof. And again, we've got, material choices listed out on the right and what all of those amounts were in. And, we can see that actually by not even drastically trying too hard, we have now reduced that to 68 tons of upfront embodied carbon emissions. So now we're going to take a look at the best conventional. So this is the one where, these products are available, and maybe you'd have to be a little more thoughtful about speccing them, but they're available. We can do it today. All right, so you saw the foundation and the slab come up. When we hit walls, something interesting happened. I hope everyone can see the screen well to see that the numbers that we're all kind of summing up, we now suddenly have a negative number, and it's in green. So let's take a second to, and the note here we can see is the frame with cellulose and wood fiberboard for the walls. So we're gonna do our second poll. Everyone get ready. Robert's gonna pull it up on screen. Why do we have a negative number here? What is happening? So I'd like everyone to just quickly answer, how can a building material have a negative carbon impact? It is plant-based. It is made of carbon. It is stored in the building. It is from a regenerative or sustainable harvesting practice and process, or all of the above.
Okay, again, we'll give the audience a couple more seconds to complete the poll. It looks like we're almost 100% complete.
We got the quickest pollsters. We love it. All right, so we should have the results here. Nice. All right, so 83% of people, you know, caught our little trick of all of the above. This is great. I mean, everyone who chose any of the other ones, you're right too. It is because it is plant-based. It is made of carbon. It is stored in the building. It is from a regenerative and sustainable harvesting process. And it is all of the above. So yeah, critical to understand. So carbon storing materials, you know, create a whole new paradigm. So they're building materials that remove carbon and store it in processes that we needed to happen anyway as human beings. You know, we certainly can have critical thought around, you know, what buildings do we absolutely need to be building? That's great, or remodeling or working with. I think, you know, rethinking what we need is going to be a part of this, but we absolutely do need shelter and appropriate shelter and shelter that is regenerative. So plant-based materials are materials that store more carbon than is emitted during harvesting and manufacturing. And again, there's a lot of really great, really fun rabbit holes to go down on all of these here listed on the right. I would encourage everyone to follow up and do, you know, a little bit more research on all of these. But so many options for carbon storing materials exist currently. You know, cellulose was named on the prior slide, which is made from waste paper. Paper is of course made from trees. So that is, you know, one material that's readily available and able to be deployed by, you know, most common construction firms and architects. It's presently available. And then there are other things that are starting to be more available, such as wood fiberboard, which you see up here. Sustainable timber is becoming more available and more understood how critical that is. When we're looking at wood, wood is a very complicated one in terms of does it store or not, because there's a lot going on with land use changes when we harvest timber. So, you know, and loss of biodiversity and all these systems things that we have to be really critically aware of. Straw bales are on here, which Jacob and I have both worked in our professional careers as builders, building with, and, you know, have had great success with, even in cold and wet climates. So that's important to know. There's a lot of other great things on this list, so I encourage people to look further into it. So on that note, we were finishing our sort of, you know, best conventional here. And so we can see the additions coming up on the screen. On the left, the yellow bar with the white numbers is showing us the things that have a net emission. And the yellow bar with the green are showing us the things that have a net reduction based on carbon storage. So we can see that the result of this building is actually storing carbon in a net manner. And then coming up on our right is the best approach. So were we to really get behind this as a society and do all of the research and development and testing and code work and, you know, skilling up our tradespeople and, you know, educating everyone, you know, and working with these, you know, deeper systems, we could really begin to create this incredible impact. So you can see again all the different choices on the right. And again, we don't have time to really unpack every single one, but I would encourage people to take a look and further break down each and every one of these that store 117 tons of carbon through one building. So what's critical here to understand, and I think this is one of the things that was kind of a hard mirror to look in for our high performance building kind of groups that we're in, is that we all were working so hard to make buildings as airtight and insulated as possible. And because we were not looking at embodied carbon as being a significant impact on the overall emissions of that building or the climate impact of that building, unfortunately adding more insulation when that insulation is a very high embodied carbon, upfront embodied carbon material like foam. There are other things we could name, but that's one of them. Unfortunately, that building actually has a greater overall climate impact than a material or a building that was made with either less insulation, if it's that bad material, or if we use good insulation, we have even greater leveraging. So you can kind of see the red bar on the top right and the green bar on the bottom left as representing kind of the opposite ends of those poles, and where we go when we change those material choices. So again, just this point, materials matter. So, you can see on the left, again, that high upfront embodied carbon, and on the right, the green best upfront embodied carbon. Those are kind of pulling our two poles of what's possible. And really, I think thinking about this, what this means at scale is what is actually just kind of mind-blowing. So in 2017, in the US, low-rise construction, so we're not even talking about, for a second, high-rise buildings, we're just talking about low-rise construction, both residential and commercial. There's 241 million meters squared of new residential construction being built. And that if we do business as usual, so on the left, we can see business as usual, continuing with, not paying attention to upfront embodied carbon in our materials choices. And on the right, we can see what happens if we do the opposite. And essentially, this is the thing that I think is worth circling on everyone's screen, is this removing emissions equivalent of 10 coal plants on the right. And on the left bottom, we have adding emission equivalent of 15 coal plants. So it's significant what we're talking about here. It's not just kind of a small thing that's happening on an individual basis. We're leveraging major change in our system here. And so again, is this realistic? What are we actually talking about here? Are these materials actually available? Are there enough of them? Is this a real thing? 2.16 billion tons of grain straw were grown globally in 2016. And again, as it says here, that is enough carbon storage to offset all current greenhouse gas emissions and more than replace all current insulation materials. So what that means is, if we were to tomorrow say we are only using byproduct grain straw to insulate our buildings, there's enough. I mean, it's a thought experiment. And so we can see on the right, there's many ways to use grain straw byproduct, and again, it's really fun to think about it often being a byproduct of food production. So there's a really cool thing to think about dovetailing there, supporting sustainable farming, sustainable agriculture, and the way that that dovetails with sustainable building and with sustainable forestry. And all of these things are industries that can really interconnect and learn from one another and leverage all those points in the system. But you can see formaldehyde-free straw panels and a SIP, where you see that SIP, that's a structurally insulated panel. It's a type of pre-built structural panel that is insulated, and in this case with straw.
All right, so we've got a pretty good basis there of the different impacts of different material selections on the embodied side of things, and how some of those change either for the better or for the worse as we move from kind of a code minimum to a sort of net zero energy ready, high performance type of building. So now we want to take a look at, let's put the operational emissions on top of that, just to give us a sense of scale and try to get some understanding of how those relate to each other and you move through the life cycle of the building into the operational phase. So here we are again. This will look somewhat familiar. We've got on the left those 4 color-coded material profiles of, in this case, I think we're looking at just the multi-unit building. We did this for both the single unit and the multi-unit, and what we're looking at now is just the multi-unit. And then on the right there is looking, that's in the code compliance, kind of code minimum version of performance. And then the right, all the same materials, but again, you'll see the high bars are higher and the storing bars are also bigger as you move towards a high performance environment with those materials. And we take that building and we put it in Boston, Massachusetts, and we heat it with a high efficiency natural gas heater. Let's look at what happens. Again, sort of holding 2050 as our sort of boundary for the time frame of operational emissions, because we know we need to get to 0 by then. So beyond that point, it becomes perhaps less relevant. So within 30 years of operational emissions in that environment, that's what we see here. So about 300 kilograms of carbon dioxide equivalent, tons of carbon dioxide equivalent leveraged on top of each one of those buildings. Remember, the performance is the same, just different materials that are reflected in the embodied carbon below. And those orange bars are the operational emissions for that 30-year period. And then we compare that to what that looks like if that was built to a high performance sort of net zero ready quality on the right there. So there's a few sort of interesting things to take there. We have about 60 tons of carbon emissions reduced over that 30 period of time by going from a code minimum to net zero quality building. That's significant. That's a tremendous win. And you know, I really give a tremendous amount of gratitude and appreciation for all of us within the high performance building industry that have worked so hard to actually make those types of reductions really accessible across pretty much all markets. What we found to be fascinating is that any given step sort of down the chain in terms of emissions or up the chain in terms of, you know, better impact from materials, any one of those steps is significantly larger than the reductions of emissions that we see across, you know, changing from a code minimum to a high performance. So that's really significant. There's a lot of impact to be leveraged in changing materials. And I would preface this by saying this is a yes and kind of a scenario here. So we're not advocating for one over the other, just showing the relative scale of impact. What was also really challenging to see is that it is quite possible to be building a high performance building using high emissions materials that is worse for the climate by 2050 than a code minimum building. And that's really sobering. That's just a matter of taking those externalities of the impacts of and the emissions of our materials. Once we bring them into the equation and really see the scale of those emissions and the relatively short time frame we have to realize reductions from the operational phase of the life cycle, that's really sobering. We run the risk of doing more harm than good without paying attention to the unintended consequences of our material selections. So let's take that building and now let's move it to Toronto, Ontario, where they have a much cleaner grid and you know, much lower emissions for every kilowatt hour of electricity produced. And we'll take out the gas heating system and we'll put in air source heat pumps. And now what we see is that our operational emissions are dramatically lower, right? We've got less carbon emitted for every unit of energy that is required to again, keep that building warm. And again, once we see that the scale of the embodied emissions becomes really big, and that there's as those operational emissions get smaller and smaller, you know, all of the impact really lies in, or much more of the impact lies in the embodied phase. And so for those of us that have been doing, you know, work in this field, not just in improving the efficiency of our buildings, but moving towards strategic electrification and getting fossil fuel combustion out of the buildings, as well as cleaning up the grid and decarbonizing our building grid. It's the combination of all of those things that really allows us to get towards a true net zero building. It's really all of those steps together that get us to zero. All right, let's do. Actually, you know, we were running a little bit late on time, so we're going to hold off on the last survey. Just getting a time warning here. So I just want to reinforce the point of that survey is to reinforce that there are really 4 points that we need, 4 things that we need to do to get to true net zero carbon. It's not only building high performance buildings, which we're getting better and better at as an industry, and we also need to remove the fossil fuel combustion from those buildings. We need to build those buildings out of carbon storing and low carbon materials, and do that on a decarbonized grid and improve reduce the emissions and improve the cleanliness of our grid infrastructure. We look at it as a system and all those different scales and points of intervention together. That's how we get to a true net zero carbon reality. And so, you know, when we talked before about looking at, you know, how traditionally we've looked at building emissions from the energy impact, and then we've been expanding that to actually look at the carbon emissions and looking at the carbon impact during the operational phase. We want to also weave in the upfront embodied carbon emissions and have a new definition of building performance that's not just about its energy efficiency, but is really looking at its carbon use intensity, not just its energy use intensity, and broadening our scope of analysis and and what we're holding as within our control to include the materials that go into creating these buildings and that are responsible for either the emissions or the storage of carbon in the construction process. So if we really want to get to zero, and that's our goal, we cannot get there without building carbon storing buildings. We have too far to go in too short a period of time to just build net zero energy houses and buildings and expect that'll get us there. We need to leapfrog past that and use our buildings as an opportunity to draw down carbon to get to zero. And again, that ties back into, and it's one thing to say that, and we really need to put that in the context of the global carbon cycle and understand that, you know, in doing so, we are, again, trying to work with existing natural systems of carbon drawdown and carbon cycling out of the atmosphere, back into the biosphere and back into the pedosphere, and use our choices around material selection to enable and support and accelerate that part of the carbon cycle. So that's the strategic plan that we want to throw down for our industry here is to stop immediately using these high carbon intensity materials. That we need to do right now and immediately switch to lower carbon and more moderate carbon sort of typical material selections that are available to us. Within the next 3 to 5 years, you know, we can adjust our design and construction practices to get towards those true zero carbon storing materials that are already available on the marketplace. And then look ahead within this next 5 to 10 years that we have within to dramatically reduce our emissions to really ramp up and accelerate production and incorporation of more of these sort of edgier, you know, optimized carbon storing materials. All right, let's look forward here to our last section of the presentation here, our path forward. So I want to give some credit to Donald Meadows, who's an amazing systems thinker. He's taught a lot about systems thinking just in a much broader span here. Reading a time for everyone, leverage points, places to intervene in a system is a phenomenal resource for looking at different ways that we can, you know, what do we do? That's always the next question. What's my next move? Like, what can I do to help participate in this? Where do I take action? So I'm referring back to her, to a riff off of her analysis of the different points of intervention we can take to enact different degrees of leverage. Again, this is a systems problem. We're looking for systems solutions. And so we need to find ways to intervene within that system to be the most effective we can be within the time we have remaining for us. And so there's we're going to start by looking at sort of the lowest order issues. Start just by counting carbon, just having an awareness and making clear those externalities. That's, you know, through various carbon calculation tools and even just attending this webinar and getting some sense of how we start doing that. That's the first step. And then as we've been talking about, the next step would be on your next building project, or you start, you know, for those of us, start using low carbon materials. And next step after that, those of you that have as an architect or as a builder, to start using those lower materials across your whole practice. And then a step above that would be not to just do less harm, but do active good, to start changing your practice over towards using, you know, optimizing carbon storage through your practice and your material selection as we sort of walk our way up the higher points of leverage. So let's give a couple of examples here and sort of start talking a little bit about how some of those, you know, and all those pieces are just around, you know, this simple solution, right, of material substitution. We know that's not enough by itself, but it is very impactful and has a really strong, you know, those are real leverage points. And what we see is, you know, we've been talking about the global warming potential, but the same analysis, life cycle analysis that tells us the global warming potential tells us this host of other ecological impacts, these other impact categories. And what we find is materials that have really low global warming potential tend to, across the board, also have really low environmental impact in these other categories. And not only that, they also tend to have much lower levels of toxicity and the toxic and health exposure both to occupants and to workers, as well as, you know, upstream and downstream in the ecological impacts of the material toxicity, and reduced waste and better waste management potential. So we can already see some of this sort of system solution opportunities manifesting, and we see some of these materials that really have beneficial impacts across multiple different categories beyond just climate impact.
So we're going to take a second to just run through some examples. Our company is a construction company, and so we are actively looking at how to implement these ideas in our work. So an example of on a retrofit, so I talked about working with existing buildings, how swapping out kind of the common practice of using foam with something like cellulose as an alternative insulation strategy can really result in less embodied carbon, upfront embodied carbon emissions of that process. And then we're going to just look through some of our other case studies of, this is also a retrofit, where instead of wrapping the building in foam board on the exterior, which is pretty common, or also mineral board is another one that is commonly being used, we used wood fiber board, which is becoming more and more available in the US. So this is just some fun looks. On the left, that's my hand holding the fluff of the wood fiber board. When you cut it through a table saw or with any kind of saw, it just is, beautiful little fluffy pieces of wood fiber. And so this is from the result of the process of logging, actually. And so it's slag, like, otherwise waste wood that would just be decomposing in the forest. So it's actually really key that this waste product is being turned into something that can be stored in the building instead. So continuing to move through, so this is actually the first passive house building that was done in Burlington, Vermont, that we were lucky enough to get to collaborate on and do the passive house envelope for, and it was just finished last year. And we used wood fiber board on the exterior of that as well. And so that was a good example of combining operational carbon emissions with embodied carbon emissions, upfront embodied carbon emissions on a project. And the one on the right is one that we actually have in process currently in Charlotte, Vermont, working with an existing building. And these are just some pretty pictures of the outside, which is always fun to see how things can finish out. On the right, really fun, we finished it with a lime plaster on the outside. It did some really cool shoshugiban, charred wood for the trim. That's that dark black trim that you're seeing, which is a way to treat wood in a different way, a non-toxic way. And the other fun thing that we've been doing is getting into straw panels, which we mentioned earlier, are a way to utilize grain straw in a good insulative way. So these are structurally insulated panels made with straw. This is a project that we finished, actually is still in process in Massachusetts. And so these are, this is our crew in the shop working on the panels. You can see the straw bales stacked up in the back, and then our table for putting them together. We also used wood fiber board as well on the panels. There they all are, stacked up, ready to go. Head down to the site. There they are. We had a lot of fun loading them onto the truck, driving the telehandler. And then here on site, raising them into place. Beautiful day. Nice to see that sunny sky and those green leaves. We're going to get that again sometime soon. And there we are, the fun point of putting that last peak up on the gable. And then, this is just a note to other, possible insulative options for insulating under slab. So this product called Glavel, which is a form of aerated glass as an alternative to foam underneath a slab, was used actually on the Burlington House Passive House project, as well as this project in Massachusetts that we just showed.
And fun fact, that's about to start being manufactured here in Vermont using 100% renewable energy. So
right.
Another example of developing technology.
Dovetailing those things. Yeah, that's great. Yep, just the interior still in process of that little cabin with those straw walls. And then also, just that it's very real that these things, it doesn't have to be a small residential building. It can be, a multi-unit apartment complex. So this is an example of the Jules Ferry apartment complex in France. And you can see that the net carbon storage was 1,100 tons.
All right, so we're right near the end here, and we've now had a decent look at some of those most immediate steps that you can take on the lower points of the lower leverage points. And we want to see, okay, so now where do we go if we're really trying to enact change at a higher degree and really address the system and hold a higher degree of leverage. So now we move into handprinting of carbon storing buildings. Now, footprinting is an analysis of the impact you've had. Handprinting is optimizing change by sharing case studies and sharing information and educating and trying to show how the changes that we're making in real time can be replicated and adopted across the industry. Some of what we're doing today. Addressing carbon in code and policy has an enormous impact and what either by carrot or by stick in terms of the impact that that'll have across the industry. Changing the culture of our industry. And what we know is that cultural changes will enact a host of different decisions made by a host of different people, not by fiat, not by declaration of mandate from a regulatory environment, but because we all really believe this is the work we should be doing, and changing the culture is enormously impactful. That's just within our own industry, and what we've been talking so much about, and what the incredible potential here is to organize cross-industry alliances with our partners and our allies in sustainable agriculture and sustainable forestry. And then really ultimately deposit ourselves within the global climate movement, to really recognize that our allies extend even beyond those that are manufacturing materials, but to those working in social justice and working in all sorts of different avenues to work towards this common goal, not just of atmospheric carbon reduction, but really creating this healthy and safe future for all of us within a balanced ecosystem. And that is, putting this work into that context gives us the opportunity to have the maximum amount of leverage and impact on changing and disrupting the system that we're in. So just to kind of spin us through some tangible examples of that on our way to the end here. Ace mentioned Project Drawdown earlier, an incredibly well-researched program of some of the top 80 to 100 solutions across all industries globally for carbon reduction. And I took a minute and went through there and found, what are all the things that relate to work that I could have an impact in my building practice right now? I found about 12 different interventions that exist in kind of like the building scale, and totaled up their potential impact. And then looked at that again for what about all the supply chain items? Always getting into how we get these materials. And we found there's twice as many points of intervention and for nearly doubling of the impact. And so that's just a really tangible example when we look beyond just, what can I do as a builder, but or as a designer, but what can we do as participants in a much larger and complex, global supply chain that has relationships with natural ecosystems? Once we start looking at that, we see this tremendous amount of potential that we have towards intervening in our systems. An example of that would be, number 24 on the list was improved rice cultivation, and that was just such a perfect, point to look at, because just this year, Cal Plant 1 came online, situated in the rice growing region of Northern California, right, in that rice area and in that agricultural area, set up their manufacturing facility to take rice straw that had otherwise been, their means of disposing of the waste straw was to flood fields with water they can't afford to use, to force anaerobic decomposition of the straw, creating plumes of methane, dramatically exacerbating climate migration into the atmosphere. Instead, they're taking that true waste product, incorporating it into a high value MDF, medium density fiberboard product. And this is close to our heart as straw bale builders. The modern straw bale movement in the 80s and 90s was born of this very similar alliance of, back then they were burning rice straw, and there was a cross-industry line to divert that straw towards high-performance building insulation materials, which is still being done today. So that's a really tangible example that's been in practice for over a generation now of how how we can dovetail those benefits. Forestry, really big one, super complex. There's so much to be said about forestry, but suffice to say, just want to draw our attention here that the impacts here go well beyond just counting, widgets of carbon stored in trees and comparing them to their, potential as an ecosystem. It really relates to land use management and land use practices, and the economies of rural America, and what it means for an increasingly urbanized global population to need reliance upon rural communities and rural economies to be able to create those materials that are needed. And that crosses political divides. We see that the industries that are the gatekeepers and sort of frontline, industries in managing our soil are forestry and agriculture, which are two of the more conservative industries around. So there's an opportunity here to bridge political and cultural divides across urban and rural divides, across political divides, and really come at this in a collective and holistic fashion. And that's really not only what's going to be required, that's a tremendous opportunity we have to bridge so many of the divisions in our society to be able to realize these benefits. So I just want to highlight here, we're not just talking about widgets of carbon dioxide. That's a huge part of it, but it goes so much further beyond that. And to optimize that, we really have to look at the systems and the people and the economies and the cultures that lead to that. Looking at the policy level, we're already there. Embodied carbon has now been accepted as a necessary point of intervention across the green building community. We're seeing certifications starting to roll out and ways of really tracking this and making this real and holding ourselves accountable as an industry, and seeing policies roll out. Our colleague Chris Magwood has been working with a township in Ontario as what we believe is the first cap on embodied carbon in the building permitting process. And we've been working together in developing the certification tool for that, which we're going to be rolling out as well. And Mass CEC is just rolling out, look for this in June, that their triple-decker competition for building retrofits that is now going to include an embodied carbon metric. And so this is where we start seeing more of these changes happening on a policy level that will impact that many more buildings.
And we've talked about this a bit, but just can't be emphasized enough, the interconnection between climate justice, climate work, and social justice, and that the who and the how matter as much as the what. And so this is about bringing everyone together and everyone forward. We've emphasized that this is about repairing relationships with Earth. I think it's about learning to be in relationship, in positive interrelationship with Earth systems in the same way that we are in positive interrelationship with each other. And those things are connected, and we must make those shifts as an integral part of what we are doing. And so climate crisis is real, it's upon us, and we do not need permission. We need bold action and conviction to make radical changes in our practice. And so we are going to charge everyone in this room to enact carbon drawdown and reverse this imbalance in the planetary carbon cycle that is the driver of the climate crisis.
All right, so we're going to leave you their top 9 things, because everyone does top 10. We're going to make it even a little bit simpler. Our top 9 things that we can do from this point forward. Build with plants that build soil.
Fix what we have.
Focus on where materials come from and how we get them.
Do what we can with the current technology and make better technology.
Change the codes and educate everybody, including ourselves, as quickly as possible.
Learn how to count carbon and what the numbers mean.
Build relationships of mutual aid with people beyond profit.
Build understanding of and relationship with ecological cycles.
And finally, act with great urgency, tremendous passion, and abundant joy, because we can't afford to burn out, and we need each other, and we need to do this in a space of joy and positivity to be able to enact this challenge in the long game.
Thank you all so much.
Thank you guys. I'm very smiley right now. I remember I saw this presentation, or a different version of this presentation last year at NESEA, and I was just like beaming at the end. And that is how I feel right now.
Yay!
Do the things. I'm excited. We have a ton of questions, and we are in no way, shape, or form going to get through all of them. So we're just going to pick a few and go from there. And we'll have some follow-up tomorrow, as we mentioned at the beginning of the session. So for the first one, a lot of people have asked a different version of this question. Is there like a carbon sequestering or a low carbon materials list somewhere? Is there a magic list that people can consult so that they don't have to, you know, reinvent the wheel themselves and someone has already done some of this background research?
Yeah, that's a great question. No, there's no one list. That's the really short answer. I think maybe one of the places that I would direct is just a good starting point. I'm actually kind of in the process of trying to develop some of those resources. I can follow up when we do our published answers with a couple of those resources, one of which will be actually sort of a white paper that Building Village for Climate Action developed, sort of summarizing and making a little more digestible the depth of the thesis work that Chris did. And so within that, there is, you know, a real highlight of a lot of these sort of hero materials that we've been looking at, and really kind of maps out, you know, some of the imagery Boyd presented before. So that's one good place to start, and we'll include some additional resources as well. But no, there's no one single consolidated list that we can just point to and be like, build with those things and we're done. That's still work to be done. So if that attracts your attention, great, there's some work to do.
But I think, you know, we have a colleague, David Arkin, who always it is David, right? Deva, am I getting that wrong? Who says, you know, build with plants, you know, not too many. Yeah. So it's basically, you know, I think understanding the principles of what carbon storage comes from is a really helpful thing to understand. Is this material possibly going to be storing or not? And there are more factors than that, but it's there. We don't have to over complexify it in a certain way. And then of course we always can, and we will, because that's who we are. But yeah.
Well, thanks. And yeah, I think it's a great idea to include some of those resources in easy linked form so that we can send people across the internet to find what they can. Another question, and I'll just phrase this more generally, how do energy codes or there's a lot of energy codes that already exist where there's not so many, quote, like carbon focused codes. Do you know of any energy codes that support carbon storage focused type buildings, or like what's the relationship between those things? Yeah,
we're so close. It's starting. I think what we're seeing is, and I'm going to expand that to not just look at carbon storage, but embodied carbon in general, which is just looking at that impact category across all materials, whether they store carbon or emit carbon. I've been in conversations with sort of National Code Council efforts to try to unpack how we can bring embodied carbon analysis into the codes. That's also happening in Canada, sort of in real time right now. And there's a project that I'm working on with BCA around in Canada about bringing that into their national code or sort of national energy kind of analysis framework. Again, Dummer Township has brought that into their building code process. It's, we're on the emergence of this. It's incredibly complicated. It's actually significantly more complicated to really figure out how to accurately and uniformly count the embodied carbon profile of materials, more so than what's, traditionally been a little more straightforward to quantify in operations. But that's absolutely fascinating. And I would say, we're seeing it in certifications like now through the zero carbon certification through ILFI and the Canadian Green Building Council. And that's, I consider that essentially precursor and laying the groundwork for actual energy code adoption. And we know that those efforts are already underway.
Cool. Thanks. Another question here. So someone was asking that you guys know, are there like larger national scale construction companies, or I guess just other construction companies that are part of this conversation around smart carbon practices, or like, do you know people that are doing this accounting as, part of their regular construction process?
I think the answer to that is similar to the answer around the codes, in that it's emerging and it is happening. And I think the more that collectively we're starting to realize how impactful this is, the more folks who are trying already to make positive change with their buildings. So people that were already working in the green building industry are, you know, ready and able and starting to implement these things. So, I mean, just briefly, we're a part of NESEA, you know, as Florence mentioned, and, you know, as is Hampshire as well. But as builders, you know, for us, it's a really important peer community where we are helping to, you know, educate each other and really importantly, share our successes and challenges with everything that we're trying, so that we're able to really quickly level up in terms of our collective knowledge and, you know, of skilling up and practicing. You know, for instance, wood fiberboard, you know, tangible example, a colleague, you know, company that many people may have heard of, South Mountain Company, you know, contacted us to walk through with one of our site leads and one of our lead builders the process of installing wood fiberboard, because we were able to, you know, get some of those kinks worked out on some of our projects and are able to share that with others in our industry. And we've mentioned Chris Magwood, our colleague, who founded the group Builders for Climate Action, which is specifically meant for builders and building companies that want to join this movement and want to act together and have access to the best information and move together as a group. So I think it is happening, and I see it changing, and I think we're going to need, you know, just that continual momentum to keep growing.
And I would say on the national scale and kind of the big industry scale, we're also seeing movement that maybe the best, like, you know, meeting place of that is the Carbon Leadership Forum, which is actually an international organization of engineers, architects, builders, construction firms, policy makers, educators, academics, that are all conversing, you know, at full industry scale around implementing change. And we do see some of the largest international firms, you know, sitting at the table there, and taking on responsibility with their power in the industry to leverage a lot of that change. So yeah, for those of you that are sort of looking for a larger, you know, more kind of national or global network around that, the Carbon Leadership Forum, which hosts the Embodied Carbon Network, which is the more sort of informal forum for having those conversations. That's absolutely a great place to meet your peers and get inspired.
Awesome. Well, I think that is actually all the questions that we have time for. Be encouraged that there is more where that came from. And I'm glad that we could end on a positive note of looking at the Carbon Leadership Forum as a good next step for people to go towards.
Absolutely.
So just for everyone else out there at the moment, as Florence mentioned at the beginning, you know, we will be posing some additional questions to Jacob and Ace tomorrow morning. So if you have other stuff that you didn't get to ask or stuff that was in the chat, if you can send any additional questions by 10 a.m. and you can just respond to the survey that'll show up at the end of this session to add any of those. Or if you have resources that you know of, if you're doing some of this work already, if you have resources that you think other people should know about and that you want to share, send those our way as well, and we can kind of network all that information back to everyone who attended. In that vein, we will be sending out an email later tonight that highlights some of the actions that all of you out there listening right now can take, no matter where you are or what your job is, you know, even if you're not someone who's designing or building buildings at the moment. So now, while you're fired up, is a good time to take action. So I encourage you to read that email. And if you do take any photographable actions, I invite you to share those with us on social media so we can kind of keep that momentum going. Other people like to see what you're up to as well. So I think that's it for me. I want to thank you all for attending, and thank you to Jacob and Ace for that inspiring and informational content, which is a niche. Thank you so much.
Great. Thank you, Sarah, and thank you, New Frameworks, for being with us and making it possible for us to offer this Earth Day celebration presentation. I just wanted to follow up again. As Sarah mentioned, once we end this webinar in just a minute or two, you will be a poll, a Survey Monkey will launch on your screen where we'd love to get some feedback about how this presentation went. NESEA and the Kern Center are both really invested in keeping to create programming that's really valuable and useful for you. That's also a place where you can add any last minute burning questions you want us to send over to the presenters. So that will launch right away. As Sarah mentioned, later tonight, you're going to be getting an email from the Kern Center that has those follow-up actions and also has a link to the survey again. So if you can't take it right now because you have to go feed your child dinner, perhaps because you've been with us for a while, don't worry, you'll have another chance to do that later tonight or tomorrow morning. And then tomorrow, our presenters will be working really hard to answer what questions they can so that on Friday, when you get another follow-up email from NESEA, maybe more the business email, which will have your certificate of attendance for people who need to report for CEUs. It will also have a link to tonight's video recording. I know some people were chatting to ask about that. And it will also have the document with the transcript of the Q&As we did cover, and also the ones that we didn't get to, either from the Survey Monkey or that were chatted in. So thanks again, everyone, for being here. It's pretty amazing to have a couple of hundred people sign on for an evening webinar. So thank you for being part of it, and happy Earth Day, everybody.
Happy Earth Day.
Okay. Thank you, everyone.
Thank you, everyone.
Thank you.